Hello and welcome to another video. This time we're going to be looking at how we take one big bitmap and separate it into smaller tiles, each with its own bitmap ID. This example tile map was created in GIMP. It's in 24-bit colour with an alpha channel. It was then exported as a raw data file. That will be in an RGBA format, with a byte for each colour. I've written a small program which will convert from RGBA 8888 to an RGBA 2222 format. That means that every pixel is stored in 1 byte of information for its colour. So I've got the tile map here, and the one which is merged data is what I'm going to convert. And so it's converted it into an RGB2 file, which is what we're going to be using in our application. If we look at this simple diagram, we can see how our image is split up into 8 columns and 5 rows, and each cell contains a 16 by 16 pixel image. We want to split it up into 32 different images, each with their own ID. So what we'll do is we'll load the file into memory in chunks, 1 row at a time. Each row will be 2048 bytes. Once a row is loaded, we'll then split it up into individual cells, and there'll be 8 in that row. Our program has a number of constants at the top here, just so that our file looks easier to read. If we look at our main program, the first section just sets up some basic parameters. We then print a little title on the screen. The important part is this line here, and this is a function that we've written to load in a file and split it up into the different bitmap buffers. Once we've got them loaded, we'll then display them all on the screen so we can take a look at them. After that, we just wait for somebody to press the escape key and then tidy up before we exit. So how does this function work? First, we define the file that we're going to open, and then we go round a loop for each of the different chunks that we're going to load, in this case 5 times. The first thing we do is clear the buffer where we're going to store the piece of data that we've just read. fread will read data from the file. It's going to read 2024 bytes and store it in the array that we've defined. This command will actually write that data into one of the VDP buffers. Chunk store ID is the one that we've defined for storing this data, which we'll be reusing each time round this loop. So this is quite a complicated command, and it does quite a lot for us. It takes the buffer that we've defined and splits it up by width, so we can define which buffer we want to split, how wide we want it to be, and how many times we're going to do it. It will then store each of those buffers into a new buffer, starting with this buffer ID and adding one for each one it goes through. So with 8 cells on each line, we'll end up with 8 new buffers, each containing data. But we can't use them as a bitmap until they've been converted. So the next loop simply goes through each of those and converts each one to a bitmap. We select the ID we want, and then we convert it from a buffer to a bitmap with this command here. We then increase the number of start bitmap ID, so each time round the loop it increases. And finally we close the file. The routine for displaying the bitmaps is quite simple. It just goes through 2 loops, one for the rows and one for the columns, and increases the number of bitmap it selects on each iteration. So we have a loop here for the number of rows, a loop for the number of columns. We select the ID we want to select, and then we plot it. And we've given it a little bit of breathing space with these numbers here, so you can see them clearly separated. So if we go over to our Agon and run the program, we can see all of our different bitmaps have been separated and displayed on the screen. I've put the blue background in here so we can see how some of them are transparent. Hopefully you'll find the C code here useful for including in your own projects for bringing in multiple bitmaps. The principles can easily be applied to BASIC or Assembler as well.